Myself Pranavi, studying in Sri Venkateswara College of Engineering from the Department of Computer Science and Engineering. Today's topic is about monitoring and controlling in scenario-based requirement analysis. Abstract. The scenarios are an effective means for collecting validation and documentation requirements at the requirement level. Scenarios describes the sequence of interactions between the software to be and the agent in the environment. Interactions corresponds to the occurrence of an event that is controlled by one of the great agent and monitored by the other. This presents a technique to analyze the requirements level scenarios for the unforeseen, potentially harmful consequence. The aim is to perform the analysis early in the system development to where it is highly cost effective. This approach recognizes the importance of monitoring and controlling the issues and extend the existing works on the implied scenarios accordingly. Uh, these uh, so, these so-called inputs output implied scenarios exposes the problematic behaviors in the scenarios descriptions that cannot be detected using standard implied scenarios. Validation of these implied scenarios supports the requirement elaborations. We demonstrate that relevance of input-output implied scenarios using the number of examples. Introduction. Scenarios-based specification language like message sequences, charts are popular for software requirement election, documentation, and validation. These describes the system executions and can it refers to the concurrent state machine models and the declarative specification. Background. These scenarios are used at an early stage of system development. Analysis technique includes detecting race conditions, timing conflicts, non-local choices, implied scenarios, pattern matching, and the model checking. Scenarios describes interaction between the components that are concurrent software process, objects, agents, hardware devices. Problem statement. It stands to the implied scenarios that are not suitable for the requirements level scenarios. Models of concurrent state machines do not distinguish between the monitor and the control events. Agents can be prevent monitored events that leads to the undetected problems. The contributions of these are defines the output and input implied scenarios, ensuring the agent that cannot inhibit the monitored events. Detection algorithms and total supports for input implemented scenarios. These case studies demonstrates the relevance of flaws relieved by the input and output implied scenarios. The key concepts are input-output implied scenarios. It specifies the scenarios arising from the monitor and the control characters. The agents observe event without controlling them, and the agent synchronizes the and control those events. Methodologies are it reviews background work on MCSs and implied scenarios, which are in section 2. It defines the input-output implied scenarios and the detection method. The third is it analyzes the published scenarios based models. And the last is it discusses the lessons learned from the case studies. Background of this are it specifies the scenarios with MSCs. MSC framework scenarios describes the interactions between the components. It partial ordering of component interactions. High level MSCs are the directed graph combining BMSCs. MSC notations visual are the visual representations of the scenarios. Modeling system behaviors with LTZ. Label train transition systems are LTZs. It formalizes for concurrent systems. It characterizes by the states and the transitions. Parallel compositions are the model that asynchronous executions and synchronizations. Implied scenarios. Implied scenarios are the scenarios present in every consistent LTCS model. It causes global versus local perspectives in scenarios based model. The examples are implied scenarios in boiler control systems. Detecting implied scenarios, it construct the minimal LTCS models and check that raise incursions. LTSA tool sets from the model checking. Outcomes are it implied scenarios or counter examples. Model elaboration with implied scenarios. Process the stakeholders validate the implied scenarios. The outcomes are the positive or negative scenarios added to the model. Iterative process, it refines the scenario based model. Methodology, it specifies the scenarios using MSCs, model system behavior using LTZs, and it detects the implied scenarios. It also elaborates the model with positive and negative scenarios. Significance, it implies the scenarios reveal potential systems flow model. The model elaborates ensure consistency system behavior. Iterative process defines the scenario-based models. Input-output implemented scenarios. The motivation of input-output implied scenarios are the requirement modeling language distinguished between the monitored and the control event. MSC models is is ignored events directions in LTC models. Standard implied scenarios may miss the flow due to the ignored events directions. IOC consistency is the LTS model cannot constrain monitored events. Input output implied scenarios, it traces the present in all IO consistent LTS models. Detecting IO implied scenarios, it constructs the minimal LTC models for each component. The arguments LTC models to prevent the constraining the monitored events. Parallel composition of augmented LTS models. Model checkings are BHMIO meaning significance. IO implied scenarios reveal flaws in the scenario based model. IO consistency ensures realistic system behavior. Detection techniques similar to the standard implied scenarios. Examples of input output implied scenarios. Uh, First ATM model, the scenario-based model with 13 VMSCs and the 1 HMSCs. No standard implied scenarios, but input and output implied scenarios exist. Input-output implemented scenarios are the ATM fields to inform user of pin code processing. Solution of this is to change the MSC model or the add the positive scenarios. Another ATM model, like four scenarios for ATM interactions, it has no standards implemented scenarios, but input and output implied scenarios still exist. Uh, the next input output implied scenarios can be user cancels transactions before ATM verification. Solution is to add the negative scenarios or to specify the ATM reactions to cancel the event. Examples of input-output scenarios as in web interface applications like scenarios-based model with 7 basic MCSs, no standard implied scenarios, but input-output implied scenarios still exists. Input-output implied scenarios can search after the failed login. Solution to it is to change the HTML events to display successful login page and display failed login page. Roster model. It is the scenario-based model with five small scenarios episodes. No standard implied scenarios. No bad error after toasting the acknowledgements. The solution is to extend the interface between the heater and the controller component. Lessons learned in the input-output implied scenarios are appears in the real scenario-based model. A detection provides the relevant feedback for requirement modeling elaboration. The implied scenarios helps to identify the assumptions and make them explicit. The last is the how to handle the implied scenarios that can become the unmanageable. Benefits of input-output implicated scenarios are to detect the unforeseen consequence in the scenario-based models, to prompt the elaboration of a further system requirement, identifying missing events, unambiguous events, and the critical domain assumption, elaborating the system behavior to cope up with the unforeseen situations. Challenges and limitations, model complexity, validating implied scenarios resulting in a large unstructured model, design discussions, correcting the issues requires scenario changes, new events and components, classification difficulties, interpreting the implied scenarios, resolving stakeholders conflicts, lack of domain knowledge and explicit relational for expecting or accepting or rejecting the implied scenarios are the limitations of these models. Conclusion: the software engineering engineers frequently use the scenarios to explicit the document and validate a system requirement because they are often the very first model to produce early analysis in the cost effective where it is the highly cost effective. This this builds upon the previous works on implied scenarios for detecting the scenarios that are not part of the scenario based model but are the present in very concurrent state machine model with consistent the scenarios. We have to show that the standard concept of implied scenarios is not suitable for analyzing the requirement level scenario because it is based on the model of concurrent state machine that ignores the distinction between the monitored and the controlled events. We have to propose that concept of input output implied scenarios that take such a distinction into consideration. We have to also develop the technique and tool that supports for detecting the input output implied scenarios In participate input output detect important problem in scenario based model that cannot be detected by standard implied scenarios. Several examples are for published scenario based models were used to illustrate the kind of problem detected and their relevance for requirement elaboration. The detection of input output implied scenarios is the only one among the other technique to be used for elaborating the requirements from the scenarios. Thank you.